Buckeye Science.
So the next thing we're going to do, a small chemical reaction with lithium and water. So I'm just going to pour some distilled water in here. And I'm going to put lithium, pieces of lithium, in both of those. But also in both, I'm going to put a little bit of indicator. You can see that a chemical change is occurring. So one of the things you're going to notice about lithium metal is it doesn't have the traditional metallic property of being shiny. It has a dull coating on the outside. It's a little shiny right there, but it's got a dull coat on the outside. And that's because the outer layer is actually covered in oxidation. And you might notice that it's got some of this kind of liquid on it. That's actually oil. We have to store it in oil because lithium is super reactive, that it will react with just the air around it and the water particles that are in the air. So if I cut a piece of lithium off here, one of the things you'll notice is that it's actually fairly soft. And you can see that the inside part is very shiny. So it's lustrous. That's a term we use to call it when we talk about metals. Metals are very lustrous, they're shiny. But if I left this out for a couple seconds here, eventually, actually fairly quickly, it would change and turn back to this dark gray, black color as the air oxidizes with it. You can already start to see it happening right there. Alright, so I'm going to cut this piece in half. And I'm going to put one piece in each of these things, these beakers over here, and we'll watch the chemical change. So we'll start with the phenylthaline. One of the first things we notice is that it reacts right away. A couple indicators of a chemical reaction here. We probably can't actually feel the heat difference there, but it is actually putting off a fair bit of heat, but it's also producing a gas. So that's an indication of a chemical reaction. So that's the indication of a chemical reaction. The other thing is you can see that the pH of the liquid changed from neutral to alkaline. That's because the lithium combined with water to produce lithium hydroxide and hydrogen gas. And that was the gas that was being produced on the top side. So it turned pink in there, which means it's alkaline. So if we toss this one in here, we would expect the same thing. However, for this one, the color when it's alkaline is blue or violet. And as you can see, where the lithium hydroxide is being produced, it's turning violet. And if enough is produced, it'll turn the whole solution purple. All right. So again, same kind of things for chemical reactions. If we could feel it, it would produce some heat, but this is too small that we're not actually, the water's absorbing all the energy. So it's not really that big of a deal in terms of heat. But gas is being produced and there's a pH change. Those are all indicators of chemical reactions or a chemical change. So lithium, if we look here, we can see now it's starting to oxidize very nicely there. It's turning back into this outer core, which is lithium oxide. So we're going to try this one more time with phenylthaline. We're going to get a top-down view of it, so you can see the reactivity more. I'm also going to toss a little bit bigger of a piece of lithium to see if we can get it reacting enough that it actually melts the lithium. The problem is the lithium's fighting between the oil and this, the fact that it's not super reactive with water. It's pretty reactive, just not as reactive as its family members. So it doesn't actually and get hot enough to melt. So now in the same group as lithium, we have sodium. So one of the things you notice about sodium is that it's a white metal. And again, it has that same dull coat on the outside, and it's stored in oil for the exact same reason as lithium. It's harder to tell from this, maybe it might be hard to tell from the video, but it's actually much easier to cut than the lithium was. And you can see it's still very, very lustrous on the inside. But again, that'll fade away very quickly. So if we take this piece of sodium, and again, I'm going to put some phenylthaline into this distilled water. The first thing you notice about the sodium is that it turned into a ball. The amount of heat that is being released by this reaction is much greater than that of the lithium. So it actually melts the sodium, which is why it forms a ball. It's kind of a ball bouncing around here, being propelled by its own reaction. The gas being released is pushing it along. It's a quicker reaction, it's a much more violent reaction, gives off a lot more heat. We have a lot of water in this to absorb that heat. So the heat's enough to melt the sodium, but not enough to ignite the hydrogen. Alright, we're going to look at the sodium reaction one more time, just so we can get a good view of the top down. That's a small piece. There we are. So that was actually pretty cool, because they started off with 2 balls and ended up going to 1. So you could actually see the 2 balls merging together because they were basically liquid. Okay, so now some of this I did off camera, but I put all the sodium and lithium away just for safety reasons. We're going to use a wire mesh for this one. So instead of having a fairly full beaker of water, we're just going to have a little bit. Still enough for it to react with, but not enough for it to absorb all that heat at the same rate. Also, I'm going to put a fairly big piece of sodium in there. But what I'm going to do right after that is I'm going to put the wire mesh over top, because you'll see why in a second. Alright? We're not going to put any indicator in this either, you're just going to watch the reaction go. 3, 2, 1. There it goes. So now, the reaction that you saw there, and if you were to touch this, it's still not that hot, but it's producing lots of gas. The gas that was produced was hydrogen, that it was now, the sodium was able to get hot enough to ignite the hydrogen. And once it ignited, it exploded, and that's what you saw there. many a ceiling tile has been destroyed by this experiment. So just wanted to give you guys a little taste of what that was like.
Buckeye Science.